So I'm just very grateful for all the presentations, and I do have a few questions for the keynote presenters and the presenters, but I would encourage everyone to participate. And so I think the first thing I've observed is that both presentations, Teams and Baylin, encode information in very different ways from very different domains. And we see then a set of presentations talking about systems in different ways. And often in systems engineering, we try, and at least culturally, try to exclude nature as something that is a little bit of a black box. Or when we include it, we oversimplify and decompose extensively. So I just wonder if you can comment on the presentations, Tim and Baylin, and how they are thinking about systems, how they are encoding this information, and what sort of advice you would have. Maybe Tim, can start with you. And then, of course, you can bring Tim. I mean, I think there's something really exciting there about SysML 2.0 and how people can now use this in all sorts of ways, is with AI, etc. But when you're thinking systems, what are the rules of thumb?
Well, in the context of systems engineering, a system is defined as an engineered system. So it's something that is created by humans for some purpose. So that's the definition. Of course, it can be also something biological. We can also create biological things, engineer biological things. But that's the scope of SysML. Of course, you can also use it in a broader context. I know that there are people out there that are very excited about SysML v2 because now we have a common language to describe problems and solutions for them of any kind. Now, if you look on the foundation of SysML, which is kernel, it's about things and connect things, and things have are decomposed by things. And so it's very high level, and you can describe anything with it. So some people already talk about that's one of the most important languages in the future because we can describe anything with it. And it has a mathematical foundation, so it's precise, you can execute it, and so it's very powerful. It's not just a description language.
Yeah, that's super interesting. But Baylin, when you presented, you came from a very mathematical optics point of view, and you modeled that solution, right?
Yeah.
Do you suggest this as yet another approach, and not necessarily use systems, but have a different framework for developing the types of things we've seen in this presentation?
Yeah, that's a very good question. I think currently we're still within the domain of traditional approaches where we try to understand or model how the way we define how the parameters we use to define this system will affect the results and try to use that to perform the optimization. I think you raised a very good question of how we could potentially use black box approach to solve the problem. I think that's actually that could be a feasible solution as well, because I think if you look at the deep learning approaches right now that people use to solve a lot of problems, I think it represents an idea of embracing this black box systematic approach that if we have enough observations, we don't necessarily have to fully understand all the details of the whole system. And as long as we have observations and we try to construct a sufficiently expressive system and try to tune the parameter to meet the observations, that would work very well as well. So I think going back to the optics problem, I think that's actually one of the things we would like to investigate in the future as well, because I think from what I've seen in the optics domain, I think some researchers are trying to move to the side of doing deep learning as well. So some of the problems I presented today, I mean, it could potentially be solved using deep learning as well. I think that would be a very interesting opportunity to see how we could use this black box systematic approach to try to solve the problem from a different perspective. I think that's a really interesting question to answer.
Right, yeah. Yes, yeah, and I would ask Professor Robert H., with the advent of SysML 2.0 and having the graphic representation, the graphic notation, and the text notation, does have a degree of resonance with your earlier keynote. Any thoughts and observations you want to share?
Yeah, so I think we're quite interested to see that SysML is now implementing units of measure, for example. But I'm not really familiar with this, but how do we go from a modeling language to an executable language? I mean, I would think that you could spend an awful lot of time. Oh, well, let me backtrack. I think it's really important that we design software before we implement it. So that is a potential role for a modeling language to get our thoughts together and to test those. One of the other papers at the ACM SIGPlan conference distinguished between thinking and action. And the presenter mentioned that when action, like writing a program, was very expensive, for example, in the early years when you had to write a program using punch cards, because the cost was so expensive, people put a lot more effort into thinking about the program they would have and designing it. So that's an argument against exploratory programming. And for, if you like, for modeling languages. But I still feel there's a disconnect, because it gets to the point where you could model something, but at some stage you need to execute it because you need to get the feedback. Your modeling is a supposition that what you have modeled will produce the results you want, but you're not going to get that reinforcement until you actually execute it and get the feedback. Oh my God, it doesn't actually behave the way I thought it would be. Oh, I've got to change my model. So the problem with a modeling language is that it's not executable. And that's why I would advocate putting things like units of measure types, not, it's really great that it's in SysML, but it needs to be in executable languages as well. But I'm not familiar with this, although I have sort of previously worked, contributed to the ISO STEP effort. How do we go from SysML to executable languages? Are there sort of code generators that will generate executable code from a SysML model? That was a question to Tim.
Yeah,
yes,
Tim. Yeah.
It's interesting. Well, just thinking what actually is an executable language. Well, SysML is executable. You can run the model, do simulations, and now SysML has also a textual notation, which is passed and executed. So, and I know there are a lot of discussions on systems engineering conferences going on. Is SysML v2 a programming language or not? So, I haven't heard a good answer to it yet.
Okay, so a programming language, an executable programming language could be driven by data. So depending on the data that you put in, you will get different results. Oh, what's the radius of this circle? I change the radius, I see the circle change. Okay, that's an executable language. Now that I modeled it, oh, the radius parameter goes into this black box called generate circle, and out comes a circle. But until I mean, I don't know, there's lots of cases in architectural geometry where I define a coordinate system by 3 points. Okay, if I move those points around, the coordinate system will invert, and my model turns upside down or inside out. Oh my God, I didn't realize I shouldn't have a negative value for Z. Okay, so I can only, okay, so there's a limit to, static programs and static verification is really important. So verification of programs, which doesn't happen in design computation, is very important. And you could do this off a static model, but some things require runtime or require a range of values, like test cases. Okay, I mean, when we develop industrial software, either at Bentley or Autodesk, we have with DesignScript, we had like 10,000 test cases. Somebody changed the program. Well, thank you very much. Upload that to the server, recompile it, not on your machine, and run 10,000 test cases. Has your so-called advancement in making the program better, has it had any side effects of breaking one of the cases? So unless you can execute it with a diverse range of input data and can evaluate the corresponding diverse range of outputs, you have a beautiful model. It's a paper-based study. So I'm very much in favor of design and modeling as a precursor to programming, and as a to resist the jumping in and doing exploratory, always just doing it by exploration. But I still want to have an integrated system where I can go from modeling to execution to testing to verification. Does SysML do that? Okay, is that part of the plan, or you're hesitating? But I'm not trying to. So the nice thing about the thing you should do about a conference is not put people too much on the spot, but just to drop in some issues which can be discussed later, or So I'm not trying to put you on the spot.
It's interesting, and if I understood you correctly, I think it still thinks that SysML can also do. So it's an interesting discussion. Is SysML execution language or not? So it's
yeah, definitely worthwhile to explore this. But I think as you showed him, the door is open, right? That door is open, and previously it was not. Yeah, and that's really fascinating. Yes. The potential it's definitely there now, when it was not before.